All right, so we talked about diffraction. That's where we ended yesterday. We talked about a little bit about diffraction. So let's take a look at it, a little review of it, because we had a couple of questions here shortly. So diffraction can occur with any type of wave, and is why, for example, you can still hear someone calling you if you're hiding behind a tree. The sound waves bend around the tree. And take a look right here. This is as water moves to this opening. See this opening right here? Which way is water moving? This way, or is it moving this way? It's moving from here to here. And you can see right here, this is a pretty small aperture or opening. Aperture means opening. The smaller the aperture, the wider the waves are when they come out of the aperture, okay? If this were wider, this would be a narrower spreading out, okay? So as the water moves through the opening shown on the right, the waves diffract. So note the waves spreading out from the opening, and you can see those right here with the little ripples, okay? Okay, so here's a question. Okay, for those of you at home, you can go back and look, you can go back and scroll back to where we first talked about diffraction. And for those of you in class here, you can go back to the slide too. You don't have to guess. Okay, so diffraction is increased when the waves pass through a large opening. Is that a true statement or is that a false statement? Does diffraction increase with a larger opening or a smaller opening? Okay, so this is saying that it increases through a large opening. Is that a true statement or a false statement? Mark your answer. You should know that. You shouldn't miss that. Okay. Here's number 32. Okay, so let's look right here at number 32. Diffraction is increased when the wavelength is larger than the opening, the wavelength is smaller than the opening, or the wavelength is similar to the opening. It's okay to be wrong. You can actually go back and scroll back a few slides and see when diffraction is increased, and looking to see if it's is it when the wave is larger than the opening, when the wave is length is smaller than the opening, or when the wavelength is similar to the opening.
Which one's gonna be?
Go back to your slides.
No, because you usually tell us
A, B, or C. There's no D there. A, B, or C. Mark your answer. You can go back and look. I'll give you a minute or so. Stay away. Focus on this lesson here. Okay, everybody got an answer? You got an answer, Joelle?
Mm-hmm.
You got an answer, Terry? Okay, let's move on. Okay, so let's look at wave interference. We talked a little bit about wave interference actually the other day. What happens when two waves exist in the same medium at the same time? Well, let's look right here. For example, think about the difference in having one music speaker on or two music speakers on. Both speakers create sound waves that exist in the air at the same time. You remember we talked a little bit about this. I think this is kind of like a review. Look right here, wave interference. Interference is a phenomenon in which two waves superimpose or add up, that's what superimpose means, to form a resultant wave of greater or lower amplitude. So look right here. Here's the aperture, the openings, right? But you see there are several here. So notice that that after the wave passes through the aperture, it diffracts, and there are regions in which the wave actually disappears. Look right in here. It actually is disappearing. It seems to disappear. Okay. So look right here. You have constructive interference, and that's when the waves that line up to each other are everywhere are considered in phase, and these waves will add up in amplitude to reinforce each other, and they get bigger. Okay, and you can see that happening here. Okay, note the waves only undergo interference when they're in the same spot at the same time. Look right here. Here we go. They're at the same spot at the same time. Okay, it seems like they bounce off each other, but each wave really just continues on its original direction. And now there's destructive. This was constructive. This is destructive, okay? Now, waves that are out of phase, and out of phase means they don't line up with each other, will cancel out their amplitude, and they get smaller. So let's look at the note here. The waves only undergo interference when they are in the same spot at the same time. Okay, it seems like they bounce off each other, but each wave really just continues on its original direction. Okay, so here's a question here. So constructive interference occurs when what? When waves cancel out or add up? Mark your answer. A or B, mark your answer, can't choose C. A or B. You remember what we said about constructive? What do they do? What do? Do they add up or do they cancel each other out? Okay, constructive. Do they cancel out or do they add up? Mark your answer, A or B. I hope you were looking. Okay, so let's go to the next one here. How about destructive? This occurs when what? When they cancel out or they add up? Mark your answer, A or B. Can't choose C. Everybody got an answer? Okay, I'm gonna move on. You at home, you can go back to your slide, through your slides, and get this information here, okay? All right, let's look at number 35. Constructive interference results in waves with a greater what? Wavelength, frequency, or amplitude? Mark your answer. And let me tell you, you can go right back here. You can go right back here. You can go right back here. You can go right back here and get that answer. You can go back to slide 80 to get that answer. You can go back to slide 80 to get that answer. Whether it's wavelength, frequency, or amplitudes. Everybody got an answer? You got an answer there, Terry? Dakota? You got an answer?
Yeah.
I need your attention up here now.
It's out of my shoes.
Yeah, now's not the time. Okay, here we go. I'm gonna move on here. Okay, so look right here. Anybody have noise canceling, ever wear noise canceling headphones? Have you ever had any, Terry, noise canceling?
Yeah, my friend got them called the turtle beaches.
Okay, so noise canceling headphones block out unwanted sounds by creating sound waves that are antiphase to the unwanted sound waves, and this is an example of what? So you're gonna block out, or you're gonna cancel out. Would that be constructive or destructive? If you're gonna cancel out something. Mark an answer, A or B. Everybody got an answer? That should be a relatively easy one right here, actually. Everybody got an answer? Okay, here we go.
I think that was the last one.
Huh?
That was the last one. Now we're on sounded and.
You're kidding me.
Yeah.
Are you kidding me? Okay, let's look and see. That is the last one. Okay, so now we're gonna stop this video, and the next video, we're gonna talk about sound, okay? Okay.